What are numbers and Boolean? Can you guess the output of the following expression if we write it in JavaScript? It's a pretty simple one, right? 0.1 plus 0.2, it should be equal to 0.3. Let's try it in the console. So if I write 0.1 plus 0.2, and you can see it returns 0.30000. What? So why does 0.1 plus 0.2 is not equal to exactly 0.3 in JavaScript? And it is not a bug, it is how computers handle numbers. And today I will share everything you actually need to know about numbers and booleans, including the weird behavior that confuse almost every beginner. So we will first talk about the number, and then we will talk about the boolean. Unlike some other languages, JavaScript has just one type for all kind of numbers. No separate integer versus decimal type, whole number, and decimals. They are both just number. And there are three special number values worth knowing. The first one is the infinity. So what you get from dividing by 0, or numbers that are too large to represent. And the negative version is negative infinity. And then there is something called NaN, or not a number. And you will see this when a math operation doesn't make sense, like trying to multiply a word by a number. So if I go to my console and declare a variable, actually define a variable, a is equal to 2, and I multiply a with a string, Hasan, you can see I get an NaN, not a number. And now here I want to introduce you to a new method called typeOf. And we can use typeOf to see the type of the variable or the value that we pass to typeOf. So for example, if I say typeOf and write a string ahead of it, it's going to give me the type of string. If I write 0.2, it is going to return the number. If I write type of true, it's going to return me Boolean. And now what would be returned if I type in NaN? It is also returning a number. And this is because JavaScript number type follows the IEEE 754 floating point standard, where NaN is a special numeric value used to represent invalid numeric results. Although it means not a number, it is still stored and treated as a value of number type. So type of NaN also returns number. And now let's come back to this sum problem that we have faced earlier. The 0.1 plus 0.2 is not equal to 0.3. The reason for that is computers store decimal numbers in binary. And some decimals like 0.1 cannot be represented perfectly in binary. The same way 1 by 3 cannot be written perfectly as a decimal in our number system, the tiny rounding difference is why 0.1 plus 0.2 comes out as 0.3000004 instead of a clean 0.3. Now, does that mean we cannot resolve this problem? Actually, we can, and with the help of some methods, we can overcome this issue. And I'm going to discuss just a few of these methods inside this video. So similar to how we have methods in strings that helps us, we have some methods that are going to help us in numbers. Here is the list of all the methods that I'm going to talk about in this video. The first one is number.isInteger. So if we have to check if a number is a whole number, then we can use this method and check whether it is a whole number or not. So let's try it in practical way. So if I type number.isInteger and I pass in 2, you can see it returns true. But if I make it 2.1, it returns false because it is no longer integer, it is a decimal number. JavaScript provides us with a math class, which is going to provide us different methods that we can use for mathematical expressions. Now what a class is, we will talk about that later because it is an advanced concept and it won't make sense right now. But just remember that in order to have the methods available for mathematical expression, we have this keyword called math. And if I type math dot, you can see we have different methods that are available to us by JavaScript by default. One of the methods that I'm going to talk about is called round. So what round does is if I pass in any value, it is going to round it off. So if the value is equal to 0.5 or greater than 0.5, it is going to round it to 1. And if I go with anything below 0.5, it is going to round it to 0. But with this, you can see we don't have the control what we want to do, whether we want to reduce the value or increase the value. So we have two other methods called floor and ceil. So what floor does is whatever I pass, it is going to go with the lower side of the value. So if I pass in 0.9, it will always be 0. So even if I pass in 0.7 or 0.9, it will always be 0, the lower side. And opposite to this, we have ceil. So these are based on the real world concept, the floor and the ceiling. Even if I pass in 0.1, it will always convert it into 1. Now there are 2 or 3 more methods that I want to talk about, and they are also on the math class or the keyword for now. And they are max, min, and random. So first let's talk about max and min. So let's say we have list of value. If I pass nothing here, you can see it returns negative infinity. But I can pass in list of values and it is going to return me the maximum value. Now similar to max, we have the min, which is going to return the minimum value of all the values that we have passed. So if I pass in 1, 5, 4, 3, it is going to return the minimum value. Now the last one that I want to talk about on math class is random. So if I simply call random, it will return a value between 0 and 1. We can also use one method on the other. So let's say math.round. And inside I'm going to pass in math.random. And it returns 1. So you can see we can combine multiple methods from the math class as well. Now that's enough of numbers for now. Let's talk about Boolean. So Booleans are the simplest type of all. Only 2 possible values, true or false. They are how your code is going to make decisions. For example, let's say we have something on our website that we need to show only to our admins. So what we can do is make variable like is admin and assign it a value true or false. In real world, we will be deciding based on whether the user is logged in and whether user has permissions. Based off this decision, I will be showing or hiding something for each of the user. Now, in order to understand how we utilize Booleans, let's first talk about operators and conditional statements.